A single-phase induction motor is an AC, alternating current, motor that is commonly used in a variety of applications, such as household appliances, fans, pumps, and compressors. It operates based on the principle of electromagnetic induction, where a rotating magnetic field is generated to induce current in the rotor and produce mechanical motion. The main components of a single-phase induction motor are the stator and the rotor. The stator consists of a laminated iron core with windings that are typically fed with a single-phase AC supply. The windings are usually arranged in two or more coils, and they are displaced from each other by a certain electrical angle to create a rotating magnetic field when energized. The rotor, on the other hand, is a laminated iron core that is typically shorted at the ends to form a closed circuit. There are two main types of rotors used in single-phase induction motors: squirrel cage rotor and wound rotor. The squirrel cage rotor is the most common type and consists of laminated iron cores with conductive bars or squirrel cages that are shorted at the ends. The wound rotor, on the other hand, has windings on its laminated iron cores, which are connected to external resistors or other external devices. When the stator windings are energized with a single-phase AC supply, they create a rotating magnetic field that induces current in the rotor windings or the conductive bars of the squirrel cage rotor. The interaction between the rotating magnetic field and the induced current in the rotor generates a torque, which causes the rotor to start rotating in the direction of the rotating magnetic field. The squirrel cage rotor achieves self-starting because the induced current in the conductive bars creates its own magnetic field, which interacts with the rotating magnetic field from the stator to generate the torque. Once the rotor reaches a sufficient speed, it continues to rotate due to the inertia of the rotor and the ongoing interaction between the rotating magnetic field and the rotor currents. The speed of a single-phase induction motor is determined by the frequency of the AC supply and the number of poles in the motor. The number of poles is determined by the design of the stator windings. Single-phase induction motors typically have lower efficiency compared to three-phase induction motors due to the nature of the single-phase AC supply, but they are widely used in many applications due to their simplicity, reliability, and cost-effectiveness. Various techniques, such as capacitor start capacitor run, CSCR, split phase, and shaded pole, can be used to improve the performance of single-phase induction motors, depending on the specific requirements of the application. Overall, single-phase induction motors are an important and commonly used type of motor in many everyday appliances and devices. Its operation is based on the principles of electromagnetic induction and the interaction between the rotating magnetic field in the stator and the induced currents in the rotor. The type of rotor used, whether squirrel cage or wound rotor, and the design of the stator windings, determine the performance characteristics of the motor, such as starting torque, efficiency, and speed. Overall, single-phase induction motors are widely used due to their simplicity, reliability, and cost-effectiveness in a wide range of applications.